Okay, we're going to start Chapter 12 today on quadratic equations and applications. And the first up is 12.1 on the quadratic formula. Well, what is a quadratic equation to start with? Well, it's a polynomial equation in the form ax squared plus bx plus c equals 0. So we get everything to one side and have 0 on the right side. And then that way we can solve the equation. And the ax squared is called the leading term. Our bx is called the linear term. And c basically is just the constant coefficient. Now note on this one, a cannot equal 0 because if we do, then it's not going to be a quadratic equation. It's just going to be a linear equation. Now we can solve quadratic equations utilizing the quadratic formula. And the other way we've done it in the past is we'll factor the trinomial and we get our factors that way. But now we're going to look at using strictly the quadratic formula. All right, well, what is a quadratic formula? So if we let a and b be coefficients of x squared and x respectively, and then c be that constant coefficient of the quadratic equation, the x squared plus bx plus c equals 0, then we can solve for x. Now again, it has to be in this order. And then we can say, okay, well, it's going to be minus b plus or minus the square root of b squared minus 4ac all over 2a, okay? And that's how we're going to solve this. We just take whatever's in front of the x squared, that's the a, whatever in front of b, the x is b, and whatever the number is, that's c. So sometimes we won't have a b, sometimes we maybe not have a c, and so it all kind of depends on what we have here. But again, a can never be 0. All right, and so again, we have to have everything on the left side and it has to be set equal to 0 to make this actually work correctly. So let's actually go through and solve some of these and see what we're looking at. Well, let's first say what are each of the terms. So what is a? Well, a is equal to 2, b is equal to a negative 8, and c is equal to a negative 2. So setting those there, now remember we have our equation that x equals a minus b plus or minus the square root of b squared minus 4ac all over 2a. And we're just going to plug those three things into this formula and then solve for x. And we should get out two. We should get a one with a plus and then one with a minus. So we're going to have two solutions to each of these equations. So we have x equals a minus b. Well, a minus 8 is going to be just 8. And then we'll have plus or minus the square root of, well, b squared. A negative 8 times a negative 8 is a positive 8 times 8 is 64. Then minus 4 times a, which is 2, times c, which is the negative 2. And then that's all over 2 times 2. Okay, now let's start simplifying. So it's 8 plus or minus the square root of, well, that's 64. Now we have a negative times a negative, so that's going to be plus. Then we have 2 times 2 is 4, times 4 is 16, all over 2 times 2, which is 4. All right, so now what we can do is we can add those together. So we get 8 plus or minus the square root of 64 and 16. That looks like it's 80 all over our 4. Now, can we simplify what is under here? In other words, is there going to be a possible square root we can take that's in here? Well, 80 is 5 times 16. So we can take the square root of both of those. Now, the square root of 5 we leave as the square root of 5, but the square root of 16 we know is 4. So that equals 8 plus or minus 4 square root of 5 all over 4. Okay. Now, what do we do? Well, we notice there's a factor of 4 in both of those, and there's a factor of 4 down here. So we can take, and if we change colors, that 4 will cancel that one once, and it'll be 2 in there. And so now we've simplified to 2 plus or minus the square root of 5. Now, if they ask us to, we could write out both solutions. We have 2 plus the square root of 5, and we'd have 2 minus the square root of 5. So we could do that. Or when we have it in this form here, plus or minus, that kind of indicates you're going to have 2 plus the square root of 5 and 2 minus the square root of 5. So those are two items there. Now, just for this first one, I'm going to go ahead and do a check. And you should probably do a check on all your problems. That way you know you have the correct solution. And so like I said, I'm just going to do it on this first one to kind of show you what you do. And remember, our equation was 2x squared minus 8x minus 2, and that was supposed to equal 0. So we're going to have 2 and then times, and then we had 2 plus the square root of 5. Oops. And you have to be careful on how you do this. And then we have to parenthesis there. And then what's inside of there is squared. And so then we have our squared for just this piece here. And then we had minus 8 times, and then we had 2 plus the square root of 5, and then our in parenthesis, and then we had minus 2. Now if I type that all wrong, we should get 0. Okay. Now to show that it works for the negative as well, we can go back up into our equation with the calculator like this. We'll have a minus there, and we'll change that to a minus there, and we should also get 0 here, which we do. Okay, and so that shows even when we have these complicated ones with radicals in them still, that when you plug it back into the original equation, you should get the correct solution, in this case 0. All right. Oops. So let's go ahead now and do some more. And again, like I said, I just showed the check on this one, but you should always check your answers to make sure you haven't done some calculation error, because you can do a calculation error anywhere in this whole formula. And if you do, then it's going to give you the wrong answer. But you know, I checked this one, it's good, and I believe hopefully the rest of these I'll do are going to be correct as well. So we have A equals here now 3, B equals a negative 2, and C equals a negative 1. And again, we're just plugging it into the quadratic formula. So X equals a minus B. Well, a minus is going to be plus 2, plus or minus the square root of a negative 2 squared is going to be 4, minus 4 times A, which is 3, times C, which is negative 1, all over 2 times A, which is 3. And so now we have 2 plus or minus the square root of 4. Now it's a negative times a negative, so that's plus. 4 times 3 is 12, times 1 is 12 still, and that's all over 6. And so now we have 2 plus or minus the square root of 16 all over 6. Now the square root of 16 is just 4, so 2 plus or minus 4 over 6. And so we'll have the two different versions. We'll have x equals 2 plus 4 over 6, and we'll have x equals 2 minus 4 over 6. And here we're going to get 6 over 6, which is 1. Here we're going to get a 2 minus 4. It's a minus 2 over 6. So that's going to be x equals minus 1/3. Okay. So that's going to be it. And if you need to, we can write that as 2 over 6, and then 2 goes in here 1, and in here 3, and then we get our 1/3 that way. All right. And again, like I said, I'm not going to show the checks on all of them. I just wanted to can check it even with those complicated ones with radicals. All right, what about this next two? Well, the next two look similar in the fact that they have a number on the right side. We don't have an actual value. And so that means we're going to have to subtract or add to get the 0 over here. So in this case, we're going to add 8 to both sides. And so that gives us v squared minus 4v, and then 8 minus 5 is plus 3 equals 0. Now this one I can see directly that it would be very easy to factor this and get our answers immediately, but we're using the quadratic formula. So we're going to say, well, a is equal to 1, b is equal to negative 4, and c equals 3. So we'll have x equals minus a minus 4 is going to be 4 plus or minus the square root of 4 squared, which is 16, minus 4 times a times c all over the 2 times 1. Okay, so we have 4 plus or minus the square root of, now we have 16 minus 12 over 2. And 16 minus 12 is 4, so we have the square root of 4, which is 2. So we have 4 plus or minus 2 over 2. And so that gives us two solutions. And the first one's going to be 4 plus 2 over 2, and the next one's going to be 4 minus 2 over 2. Well, 4 plus 2 is 6, divided by 2 is 3. And here we have 4 minus 2 is 2, divided by 2 is 1. Okay, so we got the two solutions, x equals 3 and x equals 1. Oh, I guess we changed, it should be v anyway. So let's maybe go back and change those to v. I'm good at changing letters, but we should put the right ones here. So that's v equals, v equals, v equals, v equals, v equals. Okay. All right. So then we have those two solutions. And if we would have gone back and think about this factoring, well, that's going to be v minus 1, v minus 3 equals 0. Set each of those equal to 0, and you get v equals 1 here. You get v equals 3 here. And that's what we got here, but we had to go through this process here. All right, what about this one? Well, we're going to subtract 7 to get that 0 on the right side. So we have a 3k squared plus 3k, and 7 and 4 is going to be minus 11 equals 0. Okay. Well, what is a, b, and c? Well, a equals 3, b equals 3, and c equals a negative 11. So we'll have now k equals, and minus b, which is going to give us a negative 3, plus or minus the square root of b squared. So it's going to be 9 minus 4 times a, which is 3, times c, which is a negative 11, all over 3 times 3. Okay, because 3 times, or actually it's 2 times, sorry. I saw 3, so I typed 3. 2 times a, which is 2 times 3. Okay. Now what do we have? Well, that gives us a minus 3 plus or minus the square root of 9. Now here we have a negative times a negative, so it's going to be plus. Now we have, well, we can look at it as 33 times 4, or we can look at it as 12 times 11, however you want to look at it, but that's going to be plus 132, all over 2 times 3, which is 6. So that gives us a negative 3 plus or minus the square root of, looks like 9, 10, 141 over 6. Now 141 is not reducible by any square roots, I don't believe. And so really we have two solutions. We have k equals a negative 3 plus the square root of 141 over 6, and k equals a negative 3 minus square root of 141 over 6. Okay, so in some cases you're going to get some big numbers under your square root, and that's fine. You know, just make sure it's not reducible like we saw in like this one 80, where we had 5 times 16. Now 141, it's not. If we divide that by 3, we'll get we can reduce it a little bit, but it's never going to have a square that's going to be usable there. All right, so what about the next one? We have 2p squared minus 6p minus 16 equals 4. Well, once again, what we're going to have to do is we're going to have to take that 4 to the left side. So when we do that, we'll have a 2p squared plus 6p minus 20 equals 0. All right, now we can work with these numbers, that's not a problem, but I see that there's a factor of 2 here in each one of these terms. So if I multiply everything by 1/2, that's going to reduce my a, b, and c, which is going to reduce what's in the quadratic formula, which is going to make things a little nicer. And it's going to still give me the same answer. So I'm going to take 1/2 times each term here. So that'll give me p squared plus 3p minus 10 equals 0. Now this is another one where I could easily factor this and have the answer right away, but we're going to use the quadratic formula. And so a equals 1, b equals 3, and c equals a negative 10. And so we're working with p, so p is equal to a minus 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a times c, all over 2 times a, which is 1. All right, so that's a negative 3 plus or minus the square root of, now we have 9, now we have minus times a minus, so it's plus. 4 times 10 is 40, all over 2. Now that gives us a negative 3 plus or minus the square root of 49 over 2. Well, square root of 49, guess what? That's just 7. And so we're going to have x equals a negative 3 plus 7 over 2, and x equals a minus 3 minus 7 over the 2. Okay, 7 minus 3 is 4 over 2, which is 2. And here we have a negative 10 over 2, which is a negative 5. And that's what we would have got here. If we would have factored this, it would have been x plus 5, x minus 2, and then that would solve for minus 5, and that would solve for positive 2, which is what we see here. So if we wanted to write it so we could see, and we're back to p's and again, so I changed letters once again. Oops. Whoa, now what I do? All right, so we put it back to a p, and that's a p, that's a p, and so p equals negative 5. And these would be p's as well. Okay. All right, so we got our two solutions. Now the next one, we have the x squared here and everything else on the right side. So that means we have to take two things over. So we'll have to add 7x and subtract 49. And so when we do that, we get 2x squared plus 7x minus 49 equals 0. All right, well, this is one that's not going to be too nice. We can't reduce it. So we're going to have a big number we're going to have to multiply by when we have that 4ac. So if we look at this, a is equal to 2, b is equal to 7, and c equals a negative 49. So we're going to have x equals, and now we have a minus 7 plus or minus the square root of 7 squared is 49 minus 4 times a, which is 2, times c, which is a negative 49. And that's all divided by 2 times 2. And so now we start simplifying. And oops, plus or minus. Now we still have our 49. And now we have negative times negative, so that's plus. 8 times that, so that's going to give me that's 2, and that's 39, and that's all over 4. And so simplifying there, I have a negative 7 plus or minus the square root of. Now we add those together, we get 441, it looks like, and it's all over 4. Now 441, that's one of those perfect squares, and that's really just a 21 when you take the square root of that. So we get x, or yeah, we got x this time, equals minus 7 plus 21 over 4, and we have x equals a minus 7 minus 21 over 4. And so what do we have there? Well, when we have 21 minus 7, that's going to be 14 divided by 4, and that's going to reduce to 7 halves, it looks like. And here that's going to be equal to 28 over 4, and it's negative. And so that's going to reduce 28 divided by 4 is going to be a negative 7. Okay, so we have a 7 halves and a negative 7 in the case of this one. All right. And again, what you would do is you just plug it back into your original equation, and you'd put 7 halves here, and then you'd have 7 halves here, and you want to make sure both sides were equal, as well as the negative 7 on both cases. And the negative 7 is going to be an easy one. Negative 7 times this is going to give us plus 49 plus 49. This is going to be 49 times 2, which is going to be the same thing as 49 plus 49. So that looks like it works. And if we multiply those, it's going to be 49 over 4. So it's going to be 49 divided by 2. This one's going to be 49 over 2, it's negative, plus that, and you have to get common denominator, so it's going to be 49 minus that, so that one works as well. So sometimes you can do it in your head, sometimes you have to do the calculator when you have radicals or more complicated numbers. All right, here's a couple more. These, again, like the last one on 7, we have to take it to the left side, and so what we're going to do is we're just going to add 3n and add 8. And so that's 8n squared plus 3n plus 8 equals 0. Now we're just going to plug everything in again. And so what do we have? We have a equals 8, b equals 3, and c equals 8. So we have n equals minus 3 plus or minus the square root of 3 squared is 9 minus 4 times a, which is 8, times c, which is 8. and that's all divided by 2 times a, which is 8. Okay. All right, so 8 times 8 is 64 times 4, so that looks like about 286. So that gives us -3 plus or minus square root of 9. And now it's going to be minus 286, and then divided by 16. Now, when we have a negative like this, that means we're going to end up with an I in our solution. Now, these are a little harder to check. You actually have to do it all by hand. You can't do a calculator because we don't have I in our calculator. And so, but again, we're not going to worry about the checking. We're going to assume we're going to do everything correct here and go from there. So -3 plus or minus the square root of. Now, let's see, -9, so it looks like a minus 2. Let's see. Oh, wait a second. I'm at 64. I think I wrote that wrong. 264 times 4 and 16, and that's 25. That's a 256. All right. And so 256 minus that, so that's going to be a 247 all over our 16. Now here, 247, we really can't reduce that one, but we can get rid of that negative here. And so remember, the square root of -1 is equal to I. And so what we're going to do is we're going to have n is equal to a -3 plus I square root of 247 over 16. And we're also going to have n equals a -3 minus I square root of 247 over 16. And those are going to be our two solutions. Okay. Again, we could plug each of them back into our original and check, and we should get that both sides are equal there. And remember, when you square an I, it becomes a -1. And so, there's little things we have to remember from the last chapter. All right, here, this is another one where we could easily, factor this as a difference of squares, but we're not going to do that. We're going to actually figure it out. So here we have an A, which is 4. B, well, what's that? Well, that's 0. There is no B. And C is a -64. Okay, so this is one where there's going to be no B value. And so we have A is equal to a -0. Well, it's -0 is 0, but we'll put a minus there anyway. Plus or minus the square root of 0 squared is 0, minus 4 times A, which is 4, times C, which is a -64. All over 2 times A, which is 4. Okay, so if we simplify that, well, that's just gone. So we have plus or minus the square root of, well, that's gone as well. So we have a negative times a negative is positive. And we have 16 times 64. And so if we multiply that out, 64 times 16, that's 24, 36, 8. That's a 4, that's a 6, it's a 4, it's a 12, and that's a 10. So 1024 all over 8. Okay. Well, 1024, that's one of those nice ones. And this one is a square root of, and it's going to become 32. And so we get A equals plus or minus 32 over 8. So that gives us A equals a 32 divided by 8, which is a +4. And we get also -32 over 8, which is a -4. And that's what we would expect if we would factored this and simplified that direction. Okay. What about this one? Okay, well, this one again, we have the different values on both sides, and so we have to kind of see where we would get a positive, because I'm always like positive squared terms. So I think I'm going to take the 7 in this way, so that means I'll take the 2 that way. And when I do that, I'll have 7 minus 5, so it's a 2n squared minus 3n minus 54 equals 0. Okay. Well, what does that say? Well, it says A is equal to 2, B equals -3, and C equals -54. And now I have n equals minus a -3 is 3, plus or minus square root of, well, 3 squared is 9, minus 4 times 2 times -54, all over 2 times 2. Okay. So what does that give me? Well, that gives me 8 times 54, so 54 times 8, so that's 32. That's 43. And so I'll have 3 plus or minus the square root of 9. Now, a negative times negative is plus 432 over 4. And so when I do that, that's going to give me, let's see, let's write it over here, 3 plus or minus the square root. Now, if we add that in, that's going to be 441 again, all over 4. And remember, that was a square root was 21. And so we'll have n is equal to 3 plus 21 over 4, and n equals 3 minus 21 over 4. And 21 plus 3 is 24 over 4, which is equal to 6. And 3 minus 21 is going to give us minus 18 over 4, which is a minus, well, let's put it down here, minus 9 over 2. Okay. And so those would be my two different values for n, 6 and the negative 9 halves. All right, well, what about the next one? Well, the next one, we can just get everything on the left side like we have been. Okay. And now again, we don't have a b term, and so we have a is equal to 2, c is equal to negative 13, and that b is 0, so we don't even have to worry about it. We can put it there if we want, b equals 0, but it's not going to show up in the problem really. It just kind of drops everything out. So n is equal to, now if we want, again, we can plug the 0 in, plus or minus, and we can plug it in here as well, and then it's going to be minus 4 times a, which is 2, times c, which is minus 13, all over 2 times a, which is 2. So that gives us, well, that's gone, that's gone. So we have plus or minus the square root of. Now it's a negative times a negative, so it's positive. Now we have the 8 times the 3, so that's going to be 104, I believe. So 8, yeah, 104. And then all over 4. So we can divide by 2, that's 52, divide by 2 again, so that's going to be square root of 4 times the square root of 26. Now this we can't break any part, but the square root of 4, that's 2. So this is equal to plus or minus 2 square root of 26 over 4, okay? So that's as far as we can go as far as the square roots breaking it down. But we can say, well, 2 goes in here once, 2 goes in here twice, and we can simplify it in that manner. And so we'll get 2 n's, we'll get n equals. Now we'll have the plus version, so that's going to be just the square root of 26 over 2. And we'll have the negative version, which is the negative square root of 26 over 2. And again, we can plug both of those into our original equation, and we should get our original equals 4 part there. Okay. What about these? Here we have another difference of squares, except the 6 isn't really a square, so it's not really a difference of squares. So we're just going to play as we've been doing. And so that's 6, b is 0, c is negative 1. And so we have n equals 0 plus or minus the square root of 0, and then minus 4 times 6 times negative 1, all over 2 times 6. Now that's gone, so we have plus or minus the square root of 24, it looks like, all over 12. Okay, well, 24, what is that? Well, that's the square root of 4 times the square root of 6, if we break it down. And we always want to try to get it to one of them that's a perfect square, and that's just equal to 2, so that's going to give us 2 square root of 6 over 12, and we still have that plus or minus there. Now this reduces. And so 2 will go in here once, 2 will go in here 6 times, and that means our two values are n equals a plus square root of 6 over 6 here, and n equals a minus square root of 6 over 6. Okay, so those are two values. All right, what do we have now? So now we have one where we have the back to the trinomials, and so we have just a equals 2, b equals -2, and c equals -15. All right, and so we're just going to simplify that. And x equals a minus 2, so that's basically just a 2, so we'll just put a 2 there, plus or minus the square root of -2 squared is 4, minus 4 times a, which is 2, times c, which is -15, all over 2 times 2. What does that give us? Well, it gives us 2 plus or minus the square root of 4. Now we have negative times a negative is positive, and so what we have with that is we're going to get a plus instead. So then we'll have 8 times 15, and so 15 times 8, so that's 40, that's 120, and that's all over 4. And so if we simplify that, that's 2 plus or minus the square root of 124 over 4. Now 124 we can divide by 2, so that's going to be 62 divided by 2 again, so we can have a square root of 4, and the square root of 31, I think was where I got to. And so that's going to be 2 plus or minus 2 square root of 31 over 4. Now we can reduce, there's a 2 in both the numerator and denominator, so that's a 1, that's a 1, that's a 2. And so what we get is, we get x equals 1 plus the square root of 31 over 2, and we'll get x equals 1 minus the square root of 31 over 2. Okay, so again, two solutions, and we just have the plus and the minus, which is the same as if you have the plus and minus. So, you know, right now, longhand is what we get here. All right, a couple more like this, which is how they've been. And so what we're going to do is we're going to add 6r in this case to both sides to get that 0 on the right side. So it gives us 3r squared plus 6r plus 4 equals 0. So a equals 3, b equals 6, c equals 4. And we have r, so r equals a minus 6 plus or minus the square root of 36 minus 4 times 3 times 4, all over 2 times 3. Okay, so that was our 6 squared, and then everything else. All right, so 12 times 4 is 48, so it's going to be minus 6 plus or minus the square root of 36 minus 48. That's a 4, all over our 6. And so it's going to be minus 6 plus or minus. Well, here that's going to give us a negative. We're going to get a negative 12. Well, 12 is, what we're going to have is a negative 1, a positive 4, and a positive 3. That's how we're going to break it apart, because we have that negative under that square root again. And when we do that, we're going to end up with the square root of negative 1 equals I. The square root of 4 is 2, and then we still have the square root of 3. And so that gives us a negative 6 plus or minus 2i square root of 3 over 6. And if we want, we can reduce this. 2 will go in here, 3. 2 will go in here, 3. 2 will go in here, 1. And we get two values. We get r equals, now we have a negative 3 plus I square root of 3 over 3, and we have r equals a minus 3 minus I square root of 3 over 3. Okay, and so those are our two values. Again, we have imaginary numbers once again, and so plugging those in, you know, it's not going to be hard, but you have to really consider when you take an I squared, that's equal to -1. When you take square roots of a -1, that's equal to I. So you have to remember stuff from the last chapter to be able to do these. All right, what about this one? Well, again, getting everything to the left side, we're subtract 4, subtract 6v. And so we get 6v squared minus 6v minus 4 equals 0. Now I think I'm going to get rid of some values. There's a factor of 2 in each of those. If I multiply by half, that makes the numbers a little smaller, and then I don't have to work with such big numbers in my quadratic formula. So what does that say? Well, that says A is equal to 3, B is -3, and C is -2. So now V equals, and I have a negative and -3, so it's going to be +3 plus or minus the square root of -3 squared is 9, minus 4 times A times C, all over 2 times A. And so it's going to be 3 plus or minus the square root of 9. Now we have a negative times a negative, so that's going to be plus. 4 times 3 is 12, times 2 is 24, all over 6. Okay. Now, all we have is simplifying that. 3 plus or minus the square root of, that's going to be 33, all over 6. Now that's just 3 times 11, so there's no perfect squares in there we can pull out. So V is equal to 3 plus the square root of 33 over 6, and V equals 3 minus square root of 33 over 6. Okay, so another one where that radical doesn't get any more simplified, it just stays as a kind of a semi-large number. All right, what about here? Okay, so we have to get 0 on the right side. So to do that, we're going to subtract 2k. So we get 2k squared. 6 minus 2 is going to be plus 4k minus 16 equals 0. Well, all of those have a factor of 2. So if I multiply everything by half, that gets rid of a term, so it makes that last term smaller. So it gives me k squared plus 2k minus 8 equals 0. Okay. Now this is another one we could factor and get an answer immediately, but we're going to use our quadratic formula. So a is 1, b is 2, c is -8. So we have now k equals minus 2 plus or minus square root of 2 squared is 4 minus 4 times a, which is 1, times c, which is -8, all over 2 times 1. Okay. So that gives me a -2 plus or minus the square root of, here we have 4. Here's a negative times a negative, so it's plus 4 times 8, that's 32, all over 2. So it's going to be a -2 plus or minus square root of, here that's going to be 36. Well, that's 6 times 6, so that's square root 6, all over 2. And so what we're going to have is two values. We're going to have k is equal to a -2 plus 6 over 2, and we're going to get k equals -2 minus 6 over 2. So 6 minus 2 is 4 over 2, and so we'll get k is equal to 2, and here we're going to get -8 over 2, so that's equal to a -4, and that's what we'd also have. And if we would have factored up here, we'd have got k plus 4, k minus 2 equals 0. Set them both equal to 0, we would have got -4 and plus 2. And again, that would have been almost directly, whereas this one we had to go through some steps to get to that using the quadratic formula. All right, this one we have 3 terms on the right, 1 on the left. Well, I'm just going to still take everything to the left. And that's going to be -7. That's going to be plus b. So I'm going to have a minus b squared minus 7 plus b. So I have a 6b squared minus b squared is 5b squared. Then I have plus b, and then it looks like -7 equals 0. Okay. So what do we have? Well, we have a is 5, b is 1, and c is a -7. Okay, what do we get from that? Well, these are b, so b equals a -1 plus or minus square root. Well, 1 squared is 1 minus 4 times a, which is 5, times c, which is -7, all over, and then we have 2 times 5. Okay, well, what do we get here? Well, here we have 20 times 7, so that's going to be 140, and so that's going to be a -1 plus or minus the square root. And 140 is a plus 1, so that's going to be 141 all over 10. Now the 141 we can't simplify, so we get b equals a -1 plus square root of 141 over 10, and we get b equals the -1 minus square root of 141 over 10. And so we get those two solutions to this problem. Now this is one where we wouldn't have been able to factor to get it, and that's why we really have to use the quadratic formula in this case. And that's all I have for this section.